channel Code with Fernando. In this video we are going to talk about part 3 of module 5 reactive error handling in termination. So this is going to be part 3. Okay, let's continue. doOnError side effects without handling. doOnError lets you react to errors by triggering side effects like logging, metrics, or alerts, but it doesn't handle or recover from the error. So what we need to pay attention here is to this side effect. So we need to side effect like logging, metrics, or alerts. Okay. So how it works? It executes a side effect action when an error occurs. The error still propagates downstream. The stream terminates. Okay. Use it for observation, not for recovery. This is, I think this is quite important to understand. If we want our application to recover, this is not what we use. Okay, this is just for observation. Use case examples: log errors messages to a file or monitoring system, send alerts when a specific exception occurs, capture metrics or diagnostic for failed operations. Let's continue with our code demonstration. So first, we need to simulate a service that fails. Okay, so simulate a service fails. As usual, it's going to be a flux type string. Okay, let's call this book service, and this will be flux string ever new runtime exception. Okay, here what do we do? We write the database timeout. Okay, then what do we do? We need to use doOnError to log the error before it reaches to a subscriber. So use doOnError. Okay, so here flux type string monitor book service book service. Okay, so in here let's call book service do on error. Okay, in here let's print log because we know that's what we need to do. Error, and here error, and we print the message. Simple as that. So finally we need to subscribe. We need to subscribe to the string. So we take the monitor book service, subscribe, yes, book, receive, book. Here let's print the error. Get message, and finally let's print stream completed. Simple as that. Okay, so I'm gonna explain what's going on here. We have this stream throws an error. So this is the error. Okay, runtime exception. doOnError logs the error as a side effect, but doesn't handle or recover from it. Okay, doOnError, this one, okay, logs the error as a side effect, but does not handle or recover from it. The error is still sent to the subscriber. Okay, the error is still going to go to the subscriber. The stream does not complete successfully. It terminates with the error. So we are going to see this message in this opportunity. Let's run this program. Okay, great. We are watching this one because we are logging this one. We know that. Okay. Of course, we are not getting any book, and we have seen this error. That's why we see error, get message, database timeout, because we see only one of those two, error or finally this one. In this case, we are watching the error. Thank you. Let's continue with retry. Simple retry logic. Retry is used to automatically retry a failed string by resubscribing up to n times. Okay, this is the key part in here. Resubscriber. Okay, how it works. If the string fails with an error, it retries up to n times. Each retry creates a new subscription from the beginning. If all retries fail, the final error is propagated downstream. Use case examples. Retry network calls or maybe unstable APIs. Handling temporary failures like timeouts or service hiccups. Giving systems a second chance before showing errors. Okay, let's continue with our code example about retry. So first of all, we need to simulate a counter to fail. Okay, before let's say 2 attempts. Okay, let's simulate counter to fail. The first 2 attempts. Okay, let's call that atomic integer. Let's call this attempt counter atomic integer start 0. Okay, let's after that let's create a flux of type string. Let's call this book. This is going to be our servers, and let's use this method defer. Okay, what is the meaning of this method? What does this method do? Is it delays the creation of the flux until each subscription attempt. So basically delays the creation of the flux. Just pay attention to that. So once we are here, okay, we are going to get the value of that, of the attempt counter, increment and get. Okay, so in here we are going to put the logic. If attempt is less than 3, so what are we doing here? We print attempt, okay, attempt. Let's print the attempt, okay, number of the attempt. After that, let's print service service is down. Just that. We are going to return error, flags error, and new runtime exception. Simple as that. This is going to print temporary service failure. Okay. Otherwise, what do? We print the attempt. Print the attempt, but in this case, service has recovered. So it's going to be like this: service recovered. Okay. Now we are not going to return an error, of course. We are going to return our service, our flux books. So they will be just book 1, book 2, and finally book 3. Okay, that's it. Okay, finally we need to retry. We need to use a retryer. Use a retry. Okay, so how do we use it? We take the book service, retry. So in here we need to put the number of times that we want to retry. In this case, it's going to be 2. Okay, 2 subscribe. Okay, now we know what to do in here. Let's print the book. Receive book, and here we print the error. Final error. And in here we just print the stream completed as usual. No, in here. Okay, so let's see what's going on here. We need to understand what's defer. As I told you before, defer delays the creation of the flags until its subscription attempt. Okay, the first two attempts fail. Okay, the first two attempts is going to be a failure. After that, but we try. Okay, but we try automatically retries. Okay, on attempt number three, what's going on attempt number three? The service succeeds because the condition is out. Okay, the books are emitted. These books are going to be emitted and the stream completed successfully. Okay, so let's see this in action. Great. Attempt number one, service is down. Okay, attempt number one is one. Service is down. Yeah, of course, we know that. Attempt number two, service is down. Then he changed because the attempt is become three, so it changed. Okay, service recover. Okay, service recover, and after that, what do we get? We get a book. Book one, book two, book three, and finally the stream completed. Okay, great. Okay, so why this matters? In reactive programming, error handling isn't about just try catch. We don't use try catch actually. It's about reacting to failure signals on error and choosing the right strategy. Key question to ask: should we try? Should we fall back? Should we just lock and fail? It depends on the program, it depends on the application, okay? So it's important to communicate to your team. Why it's important? Smart error handling makes your system more resilient, predictable, and user-friendly, even when things go wrong. Let's see some common pitfalls in reactive error handling. Overusing on error resume, masking real failures. Too many fallback paths can hide important bugs, so may lead to unexpected behaviors of silent data issues. Makes debugging and observability harder. Can turn fatal errors into false successes. So the we need to be very we need to pay attention to when and why to use on-error resume. Use on-error resume selectively, only when a safe and meaningful fallback is available. Number two, unbounded retries with retry. So calling retry with no limit can lead to infinite retry loops and unrecoverable errors, high CPU usage and resource exhaustion. How to debug issues if retries flood logs or downstream systems, potential service instability in production. So what's the best practice? Always specify a maximum retry count. So that's why we use this retry method, or use retry when. And with delay and exit conditions. Misusing doOnError. Side effects should be side effects. doOnError is designed for observation, not control. Pay attention to that. Observation, not control. Some common misuses. Triggering retries or restricting streams. Mutating shared state inside the side effect. Performing critical logic that assumes execution order. This can lead to unpredictable behaviors, hidden bugs, and race conditions. Violation of the reacting contract. So what's the best practice? Use doOnError only for logging, metrics, and non-extrusive diagnostics. Okay, keep business logic in operators like on-error resume or retry when. Blocking calls inside handlers. So calling blocking operations inside a reactive stream, especially in error resume or doOnError, breaks the core principle of non-blocking execution. Examples of blocking calls: thread sleep, blocking IO, future get, or thread join, for example. Consequences: thread starvation in event loops, slow response times, system-wide response degradation. So what's the best practice to avoid that? Keep our logic inside the pipeline asynchronous and non-blocking. Use reactive-friendly alternatives like mono delay, schedule boundary elastic of loading, and non-blocking APIs. Ignoring stream termination rules. Once a reactive stream sends a terminal signal, either a complete or maybe on error, the stream is finished, it's complete. Mistakes to avoid. Emitting on next after termination. You never can do that, okay? You're not supposed to do that, never. Calling on error or complete multiple times. Triggering side effects, they assume the stream is still active. Consequences, silent failures of drop signals, unexpected behavior in subscribers, violates the reactive stream specification. Best practice, respect the contract, unsubscribe, unnext, uncomplete, or unerror. So always respect that contract. Okay, finally, a summary. Here's what we have learned. Signal-based, not try-catch. Okay, errors flow through on error, not exceptions. Fallback operators. Use on-error resume, on-error return for alternative data paths. Side effects with caution. doOnError is for logging and diagnosis only. Retry with care. Use retry and retry when to control subscription. Resubscription. Why it matters. Gracefully error handling more resilient, stable, and responsive system. Okay, thank you so much.